Let us now solve a problem on Prim's algorithm. So let me just directly explain you a problem. So the algorithm and everything, they might ask definitely one of the algorithms under this topic, like they might ask Dijkstra's, Prim's, or other algorithms which comes like Kruskal and all. So you have to learn one of the algorithms. So now let us consider we have a graph over here, okay. So the graph is like this, here and here, okay. This is 1, 2, 3, 4, 5, 6, and 7. So this is a graph, and the following graph has its weight also, okay. So now here in the given question we have in this, here it is 10, and so from 6 to, okay, so I'll just copy the question. Here 26, here it's 22, here it is 12, here it is 16, and here it is 14. Remaining is from 1 to 2, that is 28, and 5 to 7, that is 24 over here, and then 4 to 7, it is 18. Okay, so this is our given graph, graph itself. So here now what we have to do, we have to like plot a matrix first. Okay, in that matrix we'll be like writing everything. So from 1 2 3, okay, so let me try to make it in this much space. 1 2 3 4 5 6 7, a bit congested, but still I think will work. Okay, so 5 6 7, so 1 2 3 4 5 6, okay, 7. So 1 2 3 4 5 6 7. So you know how like the coordinates are there. So this is 1 to 1. So wherever we have path, at that place we will be filling the cost. Okay. So 1 to 6. So 1 to 2 I have 28. Okay, and then 1 to 6 it is 10. So the remaining I don't have anything. Okay, then 2. So 2 node is here. So 2 to 1 again 28. So it's not a directed graph. Okay, it's undirected. So 2 to 7, 2 to 7 is 14, and 2 to 3 is 16, correct. And then we have from 3 to 2 we have again 16, and then 3 to 4 we have 12. So remaining just it's 12, okay, not r, okay, 12. Now coming 4th rule, so 3 7 5, so 4 to 3 it is 12, 4 to 5 22, 4 to 7 18. Then we have 5, 5 to 4, 5 to 6, and 5 to 7. So 1 2 3, 5 to 4 it is 22, and then 5 to 5, okay, nothing. 5 to 6 it is 26, and 5 to 7 is 24. Similarly you can just skip this and go for it. So 6 to 1 is 10, and 6 to 5 26, 7 to 5 24, 7 to 2 is 14, and 7 to 4 is 18. Okay, so now as you can see I have got the like matrix for everything. So now initially I'll start with 1. Okay, so now you have to see what actually happens over here. So let me show you like this. Okay, so now see here, the first step from 1. Okay, so step 1, it's visible, right? So here what happens, I think I should write it in some way much dark. Anyways, it will still work. Okay, so step 1, so from 1 first node, so whatever the path is there, I will compare which is the minimum one. So for 6, so I have only 2 paths, and the 6th one is less one, right? So the Prim's algorithm, what it does, first it selects from 1 to 6, that is 10. Okay, So in the second step, now from sixth node, it's here. It sees which is the available path. So already from 1 it's there. So the remaining is fifth, right? So it will go for fifth now. So 1, 6, that is 10, and now to 5, that is 26. Okay, and now step 3. I should go and see in 5. Check in 5. Now, so excluding the sixth one, so I have two paths again. For one is for 4 and one is for 7. Among these two, which is the minimum 22. So now what I will do, from here I will go to 22. So 10, 26. So now I will go for fourth node, which is 22. Now similarly the fourth step, now since I selected fourth node, I will go in fourth node and check which is the minimum. So excluding from 4 to 5 path, so remaining is 4 to 3 and 4 to 7 again. So which is the minimum? 12. So now I will select the third node whose path cost is 12. So 26, 4, so here it will be here 22. So now since I selected 3, here 12. Okay, so fifth step, I selected 3, so I should go now in 3. So 3, there is only two paths. So one is for 4 and one is 2. So obviously I will have to select the path which leads to 2, because if I go back to 4, it will be like there won't be any further progress itself. 3, 2. So let me write the cost: 10, 26, 22, 12, and here it is 16. Okay, 3 to 2 is 16. And then now the sixth step, so only one node is remaining. So here, since I went to 2, in 2 I have to check which is the minimum one, excluding 16. So there is 28 and 14. So I will select 14. So then I will get my complete graph over here. So we have to find the minimum cost spanning tree according to with the help of this technique. So shortest path we have to find. So this is one of the way how we achieve the shortest path. So here it should be 14. So I'll just keep it here properly so that you can take a snap of it and just keep it. I hope it's visible here also. You can slightly try to zoom in. This is the way how you solve the Prim's algorithm. So you can say here that for in the first place you have to also write the steps, right? So you cannot just do like this. For each step you have to give a theory type explanation. So you can simply say that in step 1 it compared from 1 what are the paths were there. So in the path from 1 to 2, 28, 1 to 6, 10. So it selected the minimum path. Then since it selected the node 6, in sixth place it will check which is the further nodes available. I forgot to put dash here. Okay, so it's like this. So you have to similarly have to do like this for each step. So all the steps which have been done, you have to do like that, and then at the end you have to, for each step you have to write on some theory part. Okay, you just can't leave like that in your own way. Why we selected this instead of other? See, I guess in every node we have more than one path itself, right? So like minimum two paths are there itself. So which has minimum two paths, like for example 3 has only 2, 6 has only 2, so and even 1 has only 2. So for this 3, what you can say, since from 1 to 6 was already taken 10, so the remaining was 26, that's why we moved to 26. Okay, understood? Like that you can just say something and make your own points, but remember you have to learn the algorithm. Algorithm will be available around, say you will get from textbooks and online resources also. So I just explained you the actual part of how the algorithm works, what the algorithm actually do. So usually sometimes what they will do, they will directly say use Prim's algorithm to obtain the minimum cost spanning tree. So this is the minimum cost spanning tree. Okay, and sometimes they might ask the theory what is Prim's algorithm, and design the Prim's algorithm and find its complexity, time complexity, or like that. So loops and all will be there in some algorithms, right? So we have to find the time and space complexity. So theory will be asked like that, and problems will be asked like this. So this is all about Prim's algorithm.